Welcome back to Cognitive Processes. In Chapter 9, we're going to talk about visual imagery and spatial cognition. So let's start first by talking about the dual coding hypothesis. So think about long-term memory. When you have an image of something in your long-term memory, the dual coding hypothesis is the idea that not only do you have the visual information, but you also have some verbal information about that image. And when you think about the quality of those long-term memories, the memory is best when we construct both types of coding for that type of item in long-term memory. So think about an image of your favorite dessert. You might have an image in your mind of that, piece of cake or whatever your favorite dessert is. But then maybe you have some verbal things that you talk about that, like, oh, it's a really great, piece of dessert. I had it at this restaurant. It's my favorite thing to order for my birthday. Like you have all kinds of verbal things that you include. And if you have those verbal pieces, as long as you have that with the image, you're going to have a better memory for the item. It doesn't mean that you need to have both, but if you want a high quality memory, then memory will be best if you have both. Another idea in this literature of imagery is the relational organizational hypothesis. And this is the idea that if you have imagery that you're trying to remember, um, when you have associations between items, then you're going to have better memory. And imagery produces more association between items. So I think about a paired associated task. I could ask you to remember or form an image of two items, an elephant and a bicycle. But if you form the image of the two items interacting, then you're going to have a much better memory rather than just forming those two separate mental images. So if you have this image of this elephant teetering on the bicycle, then you're going to have excellent memory for those two items as opposed to thinking about them separately. So how do we study mental imagery? Well, there's a variety of different ways that you could run experiments to understand how we engage in mental imagery. Some of them are as simple as this. You give people a letter F and then you ask them to start at the corner of the object and count the number of corners in the object. So if you have this letter F, you would start at the bottom left corner and then count how many corners there are, starting at the bottom left and then the top and then moving across, counting all those corners. You can do this by looking at the object, but you can also do this mentally in your head. And so if you ask people to do this mentally in your head, then they have no problem doing this. So they are treating the mental image of the object just like if they were looking at it. Now, it's not just about looking at the object, you can actually do things with the object. So this is an example of an experiment where you rotate images and you ask the research subject which of these are the same object rotated. And you'd think, oh, well, can the person do this in their head just like they would rotate a real object in real life? And the answer is yes, they can rotate it. And, the ability to rotate in your mind is also something that we can do in reality. So it suggests that there's some similarities between our mental images and actually engaging with the world. And if you have to look at that data and you look at how much the person actually had to rotate the image in their mind, the amount of rotation they had to do in their mind actually corresponds to the amount of time that it takes them to answer on the task, the mean reaction time. And so that's telling you that they're doing something in the mental image that they would do in reality, that those two things are happening the same way. Another way you could run an experiment is ask a subject, is the object that I first show you and second time I show you, the prime and the probe, remembering those terms, prime and probe, are they the same image or are they a mirror image? And how the experiment is set up is on the left, you get an object like a letter R, and you show them that object, and then you show them an arrow, and then you tell the subject to mentally rotate the object using the arrow as a guide. And so you take the R and then you show them the arrow and then you show them a test and you say, is that item the same or is it a mirror image? And look at, how fast they do it and how accurately they do it. And, again, subjects are able to rotate images just like they would in real life if they were actually taking the R and turning it, with a little dial. And again, imageal scanning. So let's look at a picture of a map. You can ask people, about traveling various distances on a map, and the reaction times will vary with the distance that is mentally traveled, just like if you were actually traveling across a period, an area of land. So images, mental images, are preserving those spatial relationships. So we can preserve spatial relationships when we think about a mental image or looking at something in real life. We can mentally turn things. We are often treating mental imagery very much the same as actually interacting with the world. But there are limitations. There are some buts. There are limitations. So imagine a map of the United States. Okay, mark the following locations on your map in your mind: Seattle, Boston, Reno, Los Angeles, San Diego, Chicago, New York, Washington, D.C. If I asked you a question in a study, which is farthest west, San Diego, California, or Reno, Nevada, how would you answer? Okay, do you have your answer? You've got your mental map, you have the cities, and I'm asking about those two. What's your answer? Well, the reality is most people will say San Diego is furthest west. But if you actually look at a real map, you're going to be making a mistake because, the curvature of California, curves in so that Reno is actually west of San Diego, right? So your mental map has taken the United States and kind of made it into a rectangle, right? It doesn't take into account those nuances, those details. So what you're doing when you're taking a map and making it an approximate rectangle is you're using a heuristic. It works most of the time. Heuristics are shortcuts, right? Mental shortcuts. So they work for the majority of the time, but here and there it's going to lead you to some errors. So your mental map and your real map aren't perfectly the same. They're not perfectly the same. They're close, but they're not perfectly the same. Let's look at another example of a limitation. So study this duck. I'll give you about 5 seconds to take a look at this duck. Everyone clear on this duck? Everyone got all the details? Okay, is this the same duck? I switched slides. Is this the same duck I just showed you for 5 seconds? Do you have your answer? Yes or no? Same duck? Okay, are you sure? Because the picture on the left was the first one I showed you, and the picture on the right is the second. Okay, so most people would say, if you were looking at those two pictures, that they were the same. But if I told you it was a rabbit, you'd say different, right? So when I told you it was a duck, I was priming you to focus on the bill of the image. But if I told you it was a rabbit, you would have focused on maybe the mouth and noticed the difference in the mouth or the mouth area. Because you would have thought of the bill instead of not a bill on a duck, but instead the ears of the rabbit. So if I prime you to think about something in a certain way, you're not going to notice all the details, right? You're going to notice the majority of the details, but then it can lead to some errors. And you will remember it slightly differently based on how you encoded the information. Okay, so a couple of different take-home principles about visual imagery. The first thing is that we have some implicit encoding. It doesn't have to be intentional, but we are able to implicitly encode information in visual imagery. We do have some perceptual equivalence. When you look at a mental image, for the most part, it is similar to what you would imagine would be the case if you were looking at a real object. So we have a good approximation in our mental image that is very close to reality. We also have spatial equivalence. The images retain the spatial relationships. So if I give you a picture of a map and I ask you how long it takes to travel certain distances, you're able to do that. If You have all kinds of information about spatial information. You would be able to sort of translate that from the mental image to reality and vice versa. You have transformational equivalents. Images can be rotated or otherwise transformed, and you can do that in real life, but you can also do that with a mental image. And then you have structural equivalence. The images retain the structure of the real object. There are limitations. We talked about a couple of different examples of where there's limitations, but for the most part, most of these things are generally going to be true. Okay, so we have mental images when we remember things, but we also have mental images of things that we come in contact with quite a bit. But interestingly, you could have subjects in a study looking at familiar sort of logos, and sometimes they're able to pick out exactly the perfect logo and sometimes not so much. So look at all these real logos. Which one is the real one? So they are all possible logos of Windows, but which one is the real one? Let's also look at one we might be familiar with, the Subway logo. Are you familiar with which one is actually the Subway logo? Are you sure? So in studies, you can present the different logos, and people are slightly better at identifying the Windows logo if they use Windows Computer. They might be about 58% correct as opposed to the second one, the Subway logo, maybe 48%. And that's probably just because when you log into your computer, often you're seeing the context of the logo, so you're encoding more details about it when you see it over and over and over again. The Subway logo is presented without that context, and so maybe you still are okay at it, but you still may like lose some details. But if mental images were really encoded as like pictures, then without any intention, you really should be able to do both tasks. So there is some loss of information, obviously. You get close, just like the map example, you're close, but you may not have a perfect encoding of all the details. This is another interesting study where research subjects, if you start in the center, they were given a stimulus figure, but then they were followed up with information about the stimulus figure that led them in one direction or another. So let's look at the first example. You have this stimulus figure in the middle, in the top line, and then people were either told, subjects in a study were either told this was curtains in a window or diamonds in a rectangle. And then they were asked to reproduce the figure. So after they'd seen the image and from their mental image, reproduce the figure. And when they do the reproductions are closer to what the verbal labels were as opposed to what the real image was. So you can look at, the third one down, it was like either a crescent moon or a letter C. You can see that the crescent moon very much matches the label. The letter C very much matches the label of letter C. So it's a very interesting phenomenon. It tells that it's a little nuanced, right? You're not just taking a photo of something and locking in that photo, and that's your mental image. So let's think a little bit now about spatial cognition. So when you think about space, there is the space of your body, there's the space around your body, and then there's the space that you move in, the space of navigation. That's where we move and travel. And it's interesting because our mental representations of these things may be distorted or made neater or more regular, based on the context of the task. So, you think about this space of navigation of where we travel, you might not perfectly have, an image of the space. It might get more regularized. You feel like things are more linear than they might be or something like that. So it's interesting, like we have imagery that seems so precise, but there are limitations, and we tend to make things more regularized so that we can remember them. So quick review of what we just covered. Visual images are mental representations of visual experiences. They tend to match fairly well. The dual coding hypothesis states that there are separate codes for visual and verbal information, and Two codes are probably better than one. Not all psychologists believe in the existence of two separate codes, but it does seem to suggest that there are ways to make your mental image more robust and easier to remember. And if you talk about it, then that helps maybe. Images seem to function in some ways like real pictures. They can be scanned and rotated and transformed just like real pictures can. However, mental images don't always behave exactly like pictures, and we talked about a couple of limitations of that in this lecture. And that's a little bit about mental imagery.